Hello, we're on 1.04 geometry notes today. I thought I had chosen the lined paper, but apparently it is the white paper. We're going to talk today about two super duper important formulas that will come up again throughout the year. Distance and midpoint. If you saw my shirt, if you were here on Monday, then that was the distance formula. It said social and then distance formula. So let's start with the distance formula. So distance between 2 points, A and B. So we're going to say A is the point x1, y1, and B is the point x sub 2, y sub 2. And this formula is not only just important for finding distance between 2 points, it's also how we're able to come up with a formula for a circle, because a circle has all the points on the circle are exactly the same distance from the center. So it's really just the distance formula. So distance, and we use the d equals square root. It's always positive because we're talking about a distance. In parentheses, x sub 2 minus x sub 1 quantity squared plus quantity y sub 2 minus y sub 1 squared. One way to remember this, because the most common mistake is people mix up the subtraction symbols and the plus. We don't want to end up with a negative underneath our radical. So if you have the two negatives, the two subtractions inside the parentheses being squared, even if those end up being negative, once they're squared, it'll become positive. And no matter what, when we add two positives, we still get a positive. Okay, so that is the distance formula. Now, when you are given two letters without a segment bar on top of them, so this says find IS, what that means is find the length of it. So using the distance formula, find the length if there's no segment bar on top of the two letters. And I want you to find it in simplest radical form, and you'll see on your papers or quiz tests, things like that, when I grade them, I'll say SRF for simplest radical form. So I has the coordinates 1, 0, and S has the coordinates 3, 8. Okay, and you know what? Let's also give the answer to the nearest tenth. Just for fun. So first, I want you to start writing out the distance formula in all of these. Each time you do a new problem, you're required to write the distance formula out once. If you use the distance formula multiple times within that same problem, you do not have to continue to write it out every time, one time per problem. But it is important to practice it, and by writing it out each time, it'll help you to memorize it. So now I want to find IS, so I'm going to take out D and replace it with my letters IS. Now I'm going to substitute into my formula. So to do that, I'm going to take I and I'm going to call I my x sub 1, y sub 1. And then I'm going to call S my x sub 2, y sub 2, because we said the distance formula is the distance between 2 points, x1, y1, x2, y2. So I'm going to call I x1, y1, S x2, y2, and now I'm just substituting into my formula. So x sub 2 is 3, minus x sub 1 is 1. Close it, square it. Y sub 2 is 8, minus y sub 1 is 0 squared. Now it's just order of operations and simplifying. So 3 minus 1 is 2, 8 minus 0 is 8. If those had been negatives, they'd need to be in parentheses. 2 squared is 4, 8 squared, 64. 64 plus 4 gives us 68. I asked for it in simplest radical form. If you don't know the largest perfect square that you can take from 68, go to your y1, or just you could do some guess and check, or type in 68 divided by x in your calculator, and then look for a perfect square you can take from it. So you should notice that you can take a 4 times 17. So IS is equal to 2 rad 17. And then I added on there to round to the nearest tenth. So to do that, you would type this right into your calculator, 2 rad 17, or you could even type in rad 68 and get a decimal. And that should be 8.2462. And we write that all out, then round to the nearest tenth, which is the first decimal, so 8.2. And don't just write that down from me. Make sure you actually type that in to your calculator. Number 2, find BC. So again, no segment bar, so it's saying find the length of BC. If B is 5AB, 6AB, and C is AB, 2AB, put your answer in simplest radical form. So again, let's start off by writing our distance formula. Test yourself, see if you can do it on your own here. Pause it, see if you can write it out. If not, keep writing it, and the more you write it, the more you'll remember it. Now I'm going to switch over to call it BC instead of D, because I'm going to actually put in my values here. So now I want to call my B, I'm going to call that my x sub 2, y sub 2, just to show it doesn't matter which one you call x1, y1, which one x2, y2, as long as you're just consistent. So it has to be x2, y2. It can be x1, y2. So you just have to always take from the same point. So x sub 2 is 5ab minus x sub 1 is ab squared plus y2 is 6ab minus 2ab quantity squared. And we're just going to continue to simplify. So now we have like terms here. So 5ab minus ab would give us 4ab. Really, really important here that you put that in parentheses before you square it, because otherwise you're only squaring the b, not the 4 and the a as well. 6 minus 2 would give us 4ab, again in parentheses squared. Now we want to square everything. So you want to square not only the constant, but your variables as well. So 4 squared gives you 16. And don't forget to do a squared and b squared as well. I like to say here that you've got ones on your x as your exponents, and when you raise a power to a power, you powerply, which sounds a whole lot like multiply. So multiply your exponents whenever you're raising a power to a power. Here we're going to do the same thing. 4 squared is 16, a to the second power, and b, 1 times 2 would be 2. Now we have some like terms here. They both have an a squared and a b squared. So that would give me 32. When you add with variables, remember you keep the exponents, keep them exactly the same. You just add the coefficients. So the 16 plus 16. Now we want to put this in simplest radical form. So I take the largest perfect square from 32, which is 16. 16 times 2 gives me 32. A squared and b squared are both perfect squares. Take the square root and I get 4ab times the square root of 2. So that's what BC would be equal to. 4ab radical 2. So kind of 2 examples, one very basic where you have just constants given as ordered pairs, and then number 2 where you have a little bit more challenging because we threw in some variables there, so you have to be able to work with your variables as well. Now we're going to move on to talking about midpoint formula. So the midpoint, again, same thing, is between 2 points, A, x1, y sub 1, and B, which is x sub 2, y sub 2. So I'm going to show you two different ways to do this. They're very, very similar, but one way will be more helpful when we do certain types of problems. So the fastest way is when you're given two endpoints and just asked to find the midpoint, then you're going to take the average of your x coordinates, so x sub 1 plus x sub 2, and divide that by 2. Then you're going to take the average of your y coordinates. And the midpoint is an ordered pair, so you would just go straight to looking like an ordered pair. The other way is used if you are given the midpoint and asked to find one of the other endpoints. So that we're going to say the m coordinate, the x coordinate of the midpoint is equal to the average of your x's. And the y coordinate of your midpoint is equal to the average of your y's. So it's really the same formula. It's just the second one we're adding in it, making it more as an equation, so it's easier to solve algebraically when we're given the midpoint, versus this one is easier is faster if you're just given the two endpoints, not the midpoint. All right, let's look at a couple examples. So segment QS has endpoints Q, which is 3, 5, and S, which is 7, negative 9. Find the coordinates of midpoint M. So pretty straightforward here. We're just looking for the coordinates of midpoint M, so we can use this formula over here. And I'll actually show you both ways to do it. So coordinates of M, we're just going to take our average of our x's. So first I'll label them. And then the average of our y's. So 3 plus 7 over 2. I didn't write it out again. So again, your formula, and the more you write it, the more you'll remember it. Average of your x's, average of your y's. And then our y's, we're going to take 5 plus negative 9. So that's the same thing as saying 5 minus 9 over 2. And then add up across the numerator here. 3 plus 7 is 10. 10 divided by 2 is 5. I'll write that part out. And 5 minus 9 is negative 4. So we get 5 and negative 2 for our final answer. Okay. Again, and this can be checked graphically. If you plot your 2 points, then a lot of times it's easy for students to figure out where the midpoint is just by looking at the graph. A lot of times on like the Regents exam, though, it requires you to do it algebraically. All right, let's just run real quick through the other formula so you guys can just see exactly what I mean, that they're really the same thing. So here we're going to just take x sub m equals 3 plus 7 over 2. Y sub m equals 5 minus 9 over 2. So it looks pretty familiar right from the other side. 10 over 2 is our 5. And then y sub m, negative 4 over 2 is negative 2. And then you'd still want to write it out as your ordered pair in the end. So x sub m stands for the x coordinate of your midpoint. That's what the m is for. And y sub m is the y coordinate of your midpoint. So here's where we would want to use that other one again. The midpoint, so I'm giving you the midpoint this time. And that's where you really want to train your brain to think, what am I given? Am I given the midpoint or am I given the two endpoints? So the midpoint of segment XY is M, which is 4, negative 6. X has coordinates 2, negative 3. Find the coordinates of the other endpoint, which is y. So for this one, whenever you're looking for the midpoint, you want to use that other formula with the x sub m equals the average of your x's, and y sub m equals the average of my y coordinates. This time for my midpoint, I'm going to label that as x sub m, y sub m. And then x coordinates, it doesn't matter if you call this x1, y1, or x, y2. So now I'm going to substitute in. So x sub m is 4. X sub 1 is 2. I don't know x sub 2. That's my other coordinate, my other endpoint. And then y sub n is our -6, the y coordinate of our midpoint. Y sub 1 would be -3. We don't know y sub 2. That's what we're looking for, divided by 2. Now I would take 4 over 1, put it over 1, and we have a fraction equal to a fraction, so cross multiply. So I get 2 plus x sub 2 equals 4 times 2, which is 8. And subtract over the 2 to get 6. I would pause here, do the same thing on this side, cross multiply, solve, and then check back for the answer. So y sub 2 here should have given you -9, so the final answer is 6, -9. For the coordinates of the midpoint. Now, another quick way, and I want you guys doing this algebraically in this course, but there is a nice quick way to check that I'll show you as well. So m is 4, -6, x is 2, -3, and we're looking for our x sub 2, y sub 2. So here we're going to say, okay, well, to get from 2 to 4, what do? I add 2. So to get from 4 to the x sub 2, I'm going to add 2 again. So 4 plus 2 gives me 6. Then to get from -3 to a -6, I'm going to subtract 3. So to get to the next one, from -6 to my next endpoint, I'm going to subtract 3 again, which gives me -9. So very quick for your check. But again, I want you guys to be doing it algebraically, especially being in an honors level. You guys should know how to do this algebraically. And then using this, we call this usually the rainbow method. You can use the rainbow method to check your answer, but only use to check. And we've got number 5 next. So this will be our last one. Segment CD has endpoints. C is 2 rad 150 and 2 rad 48. And then the coordinates of D are 3 rad 96 and 4 rad 27. Find the coordinates of your midpoint M. Midpoint M. All right, so this is one where I don't need the formulas because I'm given both endpoints. So I'm just going to set it up here as x, the average of my x's, and the average of my y's. So a little bit harder with our radicals here. So we'll call this x1, y1, x2, y2. So over here we'll have 2 rad 150 is our x sub 1, plus x sub 2 is 3 rad 96 over 2. For our y's, we'll take 2 rad 48 for our y1, plus 4 rad 27 over 2. So what I'm going to do is I'm going to take you through the x's, and then I'll have you do the y's on your own, and I'll give you the answer to that one. So for this side, we're going to break everything down into simplest radical form in hopes that that will allow us to combine our two terms up here, because when we're adding, we can't add unless we have the same number underneath the radical, so the same radicand. So I want to find the largest perfect square I can take from 150. So again, if you're unsure, go to your y equals, type in 150 divided by x, and scroll until you find the largest perfect square, which would be 25. And 25 times 6 will give us 150. And then 3, what's the largest perfect square I can take from 96? Same thing. If you're unsure, go to your y equals, and that should be 16 times 6. A quick trick here, if you're unsure, start with the smaller one and break it into simplest radical form, and then whatever the radical is that the number that you still have underneath the radical, try dividing the other one by that number. So if you had known 96 broke down into 16 and 6, then you know 6 is going to stay in the radical, so then you could go to 150 and divide it by 6, see if it gives you a nice perfect square. And that's if they are combinable, then that should work. So square root of 25 is 5, square root of 16 is 4. All of this in between the radicals and the constants is multiplication. So I have 2 times 5 is 10 rad 6. I can combine non-radicals together, and I can combine radicals through multiplication. But if I can't say that this side is rad 60, I have to keep it separate. So 3 times 4 gives me 12 rad 6 over 2. Now I have like terms where I can add 10 rad 6 and 12 rad 6 to get 22 rad 6. So the rad 6 stays the same. You just add the coefficients in the front. And then we can reduce this here. 22 divided by 2 would give me 11 rad 6. Pause the video here and try doing that same thing now, but for your y. So put each into simplest radical form. And then once it's in simplest radical form, see if you can combine your like terms and then reduce. Okay, and your final answer for the y's should be 10 radical 3. So those would be the coordinates of our midpoint. And that's it for us for today. So 2 extremely important formulas that you must have memorized that won't be given to you. So you need to memorize the distance formula and the midpoint formula and be able to use them in the ways that we just did. If you have any questions, let me know, and pie out.